So, hi everyone, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So with that in mind, it's always great to be here with these Ask Tom office hour sessions. And we'll go through various topics about SQL to help you understand how to use this to do things in your day-to-day job. This week, we're covering a question that came in the regular Ask Tom a while ago, and it's about calculating breach dates for support tickets. So we'll look in how to do that. Before we get started proper, as always, if you've got any comments or questions, please just put them in the question and answer. So there's two places you can send comments and stuff to us. There's the chat panel and there's the question and answer panel. We prefer it if we could use the question and answer panel, because then we can actually get a thread and follow up on those comments. It's easier for the other people participating to see what's going on. But I think I'm keeping half an eye on both of them, so to see what's going on. Like I say, just if you're not sure about any of this, let me know. I've got this session planned out in terms of topic we're discussing. If you've got any other questions, if we've got time at the end, then you can ask those as well. We'll see if we've got time. I'm not sure if we will. So with that covered, let me just share my screen again quickly and bring the slides up again. Okay, so as I said, welcome and to Ask Tom Office Hours. So it's a problem which many of you are familiar with one way or another. Working in IT, you've probably either spent time on a support desk of some description or had to send tickets to a support desk of some description and waited for response. And the response times for these are not always as fast as they should be. And someone in management has been looking at these support tickets and going, you know, we've been breaching our SLAs. We're taking too long to respond to things. Customers are complaining. We need to sort it out. We need a report so we can see when tickets are about to breach. So what we need to do is have a list of the open tickets and their breach date. Or perhaps better, just show the tickets that either are due to breach today or maybe tomorrow as well. So we can see and prioritize the things that need to be dealt with now or soon to make sure we stay within our SLAs. So that's kind of the background to the problem. We want to find things that are reaching their SLA. So the SLAs are defined like this. You're probably all familiar with different priority levels. So P1 is the top priority, the thing that's got to be dealt with quickly, down to P5, things which kind of, they're really just wishes a lot of the time rather than real problems. So the higher the priority, or the lower the number, the quicker that we have to deal with it, triage it or close it, whatever the SLA demands in terms of response time. So priority 1, 4 hours, down to priority 5, 55 hours. Now, there's a subtle difference between these, how the priorities are handled, and we can split them into two groups. Those that are dealt with 24/7 and those that are only dealt with during business hours. So priority 1 and 2, doesn't matter when a ticket is raised, you've got 4 hours to respond and deal with it. Same for priority 2, except you've got 8 hours. However, priorities 3 to 5, you only have to be, the SLA counter only activates during business hours, which in this case we've defined as 7 a.m. to 6 p.m. Monday to Friday. So that means we don't need to worry about weekends and stuff. Now, that makes calculating the breach day for priorities 3 to 5 kind of tricky. Because if you raise a ticket on Friday, you've got to skip 2 days before you then get to the next working day. So from raise date, there could be a number of non-working days which cover the elapsed time, but don't cover the SLA burn time, so to speak. So we need to find a way to skip over those non-working hours and days so we calculate the SLA breach time correctly. So let's look at a couple of examples of how this works in practice. So let's imagine it's currently a Wednesday and it is 4 p.m. on a Wednesday. So a ticket is raised 4 p.m. on Wednesday. Priority 1, got 4 hours to respond to it. Business closes at 6 p.m., doesn't matter. We've got to add 4 hours to 4 p.m., meaning we have to have triaged it, resolved it, whatever the SLA breach means, by 8 p.m. that day. What about a priority 3 ticket? So that's raised at 4 p.m. We've only got 2 working hours till the close of business that day, 6 p.m. Then the clock doesn't start counting again until 7 a.m. the next day. So we haven't actually used a full working day up until 4 p.m. the next day. And one of the things you may have noticed, so our working hours are 7 a.m. till 6 p.m. and prior to SLA hours was 22 hours. 7 a.m. to 6 p.m. is 11 hours. So priority 3 is really 2 working days. Our priority 4 was 4 working days, and P5 was 5 working days. So we got our ticket raised 4 p.m. on a Wednesday, then we got until 4 p.m. on Friday to deal with it, because that's our working days here. What about a priority 4 ticket that is raised on 4 p.m. on a Wednesday? Who wants to take a guess on which date and time this is going to breach? So priority 4 is 44 hours, 4 working days. What will be the breach date for this ticket? Put your suggestions in on when that is going to be closed, or when you think the breach date for that will be. So we've got a guess here from Siva, Tuesday, 4 p.m. So let's think about this. So we start, it's raised on Wednesday, go through to Thursday, 4 p.m., 1 working day, Friday, 4 p.m., next working day, go to Saturday, that is a non-working day. Same for Sunday, non-working day. Then we get to Monday, our next working day, and then Tuesday at 4 p.m. So those are our 4 working days. So as Siva says, we breach at Tuesday at 4 p.m. We have to skip over Saturday and Sunday. Nice and easy, straightforward, right? Well, what if Monday is a non-working day? So a lot of countries have public holidays, and quite often those public holidays fall on a Monday. And a lot of businesses consider those to be non-working days. Good example of this happened just a couple of weeks ago. Many of you may have celebrated Easter. Easter Monday, at least here in the UK, is a non-working day. And actually, here in the UK, it gets even more interesting. Good Friday is also considered a non-working day here in the UK too. So actually, we've got 4 non-working days back to back. And the interesting, aside from the fact that we need to skip over those dates, another interesting challenge here is the date of Easter changes every single year. There's a, I forget, 5 or 6 week window during which it can fall, and it can move around between those every time. So other than by kind of looking up and finding when Easter is on a particular day, you can't really write an algorithm, or it's tough to write an algorithm to figure out when it's going to fall. So we need some complicated logic potentially to handle this. But Easter's kind of exceptional, right? Other public holidays, such as Christmas Day here in the UK and many other countries, 25th of December. So 25th of December is always a non-working day. Well, that's true. But if the 25th of December happens to fall on a Saturday or a Sunday here in the UK, the public holiday moves to the Monday after. So it's the Monday after the weekend that becomes the next working day. So these working days can move around, and the working hours can change as well. I've worked a few different places in my life, and quite a few of those on Christmas Eve actually close for business at about 12 p.m. on the non-working day. So question from Raj, why are you spending so much time on non-technical part here? So I'm setting some context and background here to help you understand what the problem is. I think it's very important to always understand what the actual problem you're solving is. Quite often, If you just dive straight into SQL, straight into solutions, you don't get the context, and it then becomes harder to apply this to other scenarios. This is a technical session. We will be discussing SQL, but I think it is important to cover the wider context of why you're doing this. It's good to kind of get some background about what's really going on, what you're trying to resolve here, rather than just jump straight into some SQL. Okay, so I'm not here to give you a blow-by-blow description of syntax. That's what the documentation is for. I'm help you to try and understand the reasoning behind doing different things, and try and help understand why different things might work. Okay, so as we said, working days can change, but also the dates you work can change as well. So as I said, a lot of places I work, Christmas Eve, the business finished for Christmas on midday or 1 p.m., early in the afternoon. So the working hours changed as well. So it wasn't just the starting time, it wasn't just the day that work that changed, the working hours could change on each day as well. And it's worth bearing in mind that the business might change as well. Maybe some point in the future, they'll decide Saturday and Sunday are working days, maybe with different working hours, or maybe the SLAs will change as well. Maybe it's felt that 4 hours is way too long to have responded to a priority 1 ticket. It needs to be 2 hours, for example. Maybe priority 5s, because they're just of so low importance, we can actually push that out to 2 weeks or something like that. So a lot of these things can change here. So in terms of things that can change here, we can see the SLAs themselves could change. There might be a business review, and it's decided that we need to tighten up the SLAs or loosen them, depending on what business needs are. The working days can change. It's not just strictly each weekend is a non-working day. That might change in the future, changes the business, but also public holidays change each year. And the working hours can vary from day to day as well. So with all these changeable things, the key insight here is we need to make this data-driven. You need to kind of store these values in table somewhere so we can make it configurable, so that should any of these things change, our code is resilient. We have to make relatively few changes to what we've written. So that implies we need a whole bunch of tables here storing this information. So we already had a tickets table, but there's a couple of other tables I'm going to create as well. So we got our tickets, which have a priority and a raise date, but we've got a priorities lookup table, which stores how many hours are in the SLA and whether or not that is business hours only. So do we only do that Monday to Friday, 7 till 6? Or is it 24/7, basically? Then we need to know for each individual date whether or not it is a working day. And if it is, what those working hours are. So again, we've got a is working day flag, and then a table storing the start and close times for the business. So we know when to start the counter for the SLA and when to finish it for those working hours. So we've got this table. We can then use this to calculate the breach dates for these different tickets. Now, I'm not going to go into the details of calculating the SLA for the breach date for priority 1 and 2, because all you need to do is add the hours to the date. That's pretty trivial. I'm going to focus on those priorities 3 to 5 tickets, because those are the things where we need to skip some days to actually figure out what the breach day really is. So how can we do it? Well, it's kind of a multiple steps to this algorithm, or the one I'm going to describe here. First step is we want to generate a set of possible breach dates. So we want to say, starting from the date the ticket was raised, generate a list of possible dates in the future when the ticket might have breached. Because, in the general case, we don't know exactly what that breach date will be. So we're going to just create a set of candidate breach dates and use that to find when the number of SLA hours have been used up. So how do we do that? Well, we then need to calculate for each day how many working hours have been consumed by the end of that working day. So we saw that ticket raised 4 p.m. on Wednesday. By the end of that day, we've only had 2 working hours actually used. Thursday after, we've then got 11 hours in working day plus the 2 hours we used, 13 hours used, and so on. So for each of the dates we calculated in step 1, we're then going to get the running total of working hours used by the end of that day. And finally, to find the date that the breach actually happened, we will find the row or the date where the SLA hours for the total use at the end of the day, or the working hours at the end of the day, is greater than the SLA hours, and the working hours used at the start of the day or the previous day was less than it. So we got yesterday's total working hours, today's total working hours at the end of the day. Which date is the SLA hours fall between those 2 values? And that is going to be the date and time when the ticket actually breaches. So that allows us to find that. So questions, comments at this point before we dive into some SQL and see how we actually do this. Okay. No, I'm not seeing anything at the moment. All right, so now let's walk through some of the SQL and how we actually do this. So the first thing we need to do is generate those rows. So just joining all the tables together again. So tickets, priorities, and dates. So this looks something a bit like this. Now the interesting thing here is this bit where we are joining the dates table to the tickets. So the first date is the one that the ticket was actually raised on. So take the start of that date, trunk the date of the ticket raised, find all the dates greater than or equal to that. So that is our lower bound. Now, we could leave this second criteria off here and just find all the dates after the raise date for that ticket. But then that upper bound could be quite large. You know, how many rows into the future have we generated calendar dates? Excuse me, maybe we've been quite conservative and are only storing dates a month into the future out. Or maybe we're storing a year out. Or maybe someone's just gone whole hog and stored all the dates from today into the end of this century, or, you know, the year 10,000 or something daft as well. So potentially there are a lot of possible dates we are going to generate here. Of course, the working time for a P5 ticket is 5 working days. Even taking big blocks of time like the Easter public holidays here in the UK, then, you know, we're not going to have hundreds of days that we need to consider. So let's take Easter as an example. Let's imagine somebody raises a ticket towards the end of Maundy Thursday, so the last working day before Easter here in the UK. So Friday is a non-working day, so we don't increment the counter. Saturday is a non-working day, so is Sunday, and so is Easter Monday. So it's not until we get to the Tuesday after that we have a working day. So we had 5 elapsed days, but only 1 actual working day. We get to the end of that week, so there's the 4 working days in that week. We've then got 9 elapsed days, but only 4 working days. So we need to skip a weekend as well. So it's not until the following Monday. So 11 elapsed days for 5 working days in total. So there could be quite a large, relatively large upper bound for how many possible days we get to before we find our breach date. So we've got this raised date time here. We want to set some upper bound, so we're not considering every date in the possible future forever. But equally, we don't want to set this value too low. We can't just add 5 working days here because we're saying only look at the next 5 days. If either we don't have enough dates in this the dates table, or we set this lower bound too low, so we'd set it to, say, 8 or 9 days, someone raised that ticket just before Easter, this whole algorithm is going to fall over because we haven't seen far enough into the future. So we need to set an upper limit here, just so we don't consider everything, make the SQL run quicker, but set it too low and everything will fall apart. So this needs to be the number of elapsed days at, greater, ideally quite a bit greater than how many days can elapse from the time a ticket was raised to when it breaches, not how many working days there could be. So we put this check in here just to kind of reduce how many rows we have to consider in our final data set. Set it too low and the algorithm's going to go wrong. Set it too high. Problem with setting it really high is the SQL will be slower because we have to consider more dates in the future. So, questions, comments on that? Okay. I'm going to give a demo which will hopefully demonstrate this in a bit more detail coming up. So if you're scratching your head a bit, just sit tight and hopefully the examples will show in a bit better what's going on. So the next thing we need to do is actually calculate how many working hours have been used by the end of each of these dates that we've found. So we've got all these dates, how many working hours have been used by the end of that date. So how do we do that? Well, we can use the sum function as an analytic to get the running total. And what we need to do here is take the end of the working day, last working hour of that day, and subtract off the start of the working hour. So this is when the business closes that time. So we take the date, add on the close hour, divide by 24, because unit of arithmetic in Oracle database is the day. So we need to convert this into hours. That's what our units are, to get 6 p.m. on that day, and subtract off the time work started on that day. So this is a little bit more complicated because, of course, if the ticket is raised today, we don't want to start calculating working hours from business opening hours, 7 a.m. that day. We want to start calculating it from the time the ticket was raised. Otherwise, if the ticket's raised at the end of the day, you end up losing almost a whole working day of your SLA before the breach. So we need to take the greatest of the date plus the business start hour and the date the ticket was raised. So that finds us what time we started working, or what time we could have started working that particular day on that ticket. Subtract the two, and then, as I said, we will calculate the running total of this for each of these days. So we've got that over here. Now we actually have to do this twice. Why? Well, I said to calculate breach, we need to find the row where the SLA hours is between the total working hours at the end of yesterday and the end of today, or the end of the previous day and the end of the current day. So we've got our two windowing clauses here. Start off with just total for today, split it by ticket, calculate, sort by date. What is the running total working hours used at the end of the day? Pretty straightforward. Then to get it for yesterday or the previous day, we want to get the running total for all rows up to, but not including, the current row. So by default, we have a windowing clause of range between unbounded preceding and current row. So that's all rows with a value less than or equal to the current row. What we want to do is sum up the working hours for all the rows up to, but just before the current one. So we do that. So hours end day, do that with order by rows between unbounded preceding and one preceding. Everything up to, but not including the current row. So that gives us the working hours used at the end of yesterday. We've got the working hours used at the end of today, or the current day. To find the breach day, we just need to find the row where the SLA hours falls between those two values. Nice and easy to say where the SLA hours is between those two extremes. Pretty straightforward at this point, right? There is a tiny subtle thing that you need to look for here. So I said where the SLA hours is greater than or equal to the previous total, so the working hours at the previous day and the working hours at the end of the current day. What does that mean if a ticket is due to breach at exactly 6 p.m. One day? So at exactly the time business or work finishes on a working day. What does that mean for our breach day? What day is it then going to fall on? Well, this means that we won't consider the ticket to have breached until the start of the next working day. Now, this is something, this is one of these edge cases. You need to sit and talk with whoever's drawing up the SLA agreements and find out what they really mean about this. If something is due to breach at exactly the end of business on one day, do they take the hard line and say, you've got to have dealt with that ticket, you've got to have addressed it by that point? Or do they take a more pragmatic approach? Because in reality, if something is due to breach at the end of the working day, whoever raised that ticket probably isn't going to look into it or follow it up in any meaningful way until the start of the next working day, right? Or if they are, if they care about actually having it done, they're going to be on the phone to you and saying, where's my ticket? What's going on? Sort it out, please. So there's this subtle difference between having the cutoff at exactly the end of the working day when the breach finishes, or the start of the next working day when after that hour. So tiny thing, but it is worth sitting down with whoever is drawing up the rules on this and find out what they exactly mean. Do they want the hard line, you've got to have dealt with it 6 p.m., or does by 7 a.m. the next morning actually okay, and you're still within SLA? It's a business decision, right? Depends on what their tolerance is and how they want to handle this. Okay. Questions, comments at this point? No? Okay. Not seeing anything. So we've talked a lot about how to calculate the breach for these tickets that are only handled during working hours. What about those 24/7 tickets? Well, it's just you add the SLA hours to that raise date. Now, you could try and crowbar all of that information into the query we've just done and have some kind of case expressions figuring out whether it's 24/7, whether it's business hours only, when to fit it, and so on. Personally, I think it's probably easier just to handle each of the cases separately. Have your business hours only logic, which we just kind of walked through, and the all hours logic, and union them together. Make your code a little bit cleaner, a little bit easier to understand. So you don't have to clutter up and try and say, if it's 24/7, then do this, and blah, 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 blah. Of course, you are welcome to try and merge it all into one mega query, but that's going to get trickier for people to understand in the future. Okay, so I'm going to jump over to a demo at this point, and we will see how this works. All righty then, so let's bring this up. Okay, so I've got a table of tickets here. Let's just check, still connected? Yeah, there we go. So we've got our 5 tickets, and they're all priorities 3 and 4, and they are raised, go away, on 8th of April, so a couple of weeks ago. So when are they going to breach? Well, let's walk through the algorithm again a bit. So we will see, I'm going to calculate it just for this ticket here, make it a bit easier to see what's going on. So first thing is we're generating out all possible breach dates. So we've got, or candidate breach dates, I should say. So we've got 20 odd rows there, and we can see various of these are not working days. Those are ones we want to skip over. They've got no business hours start and end. So we've generated out our 20 dates. Now, I was talking earlier about what happens if you exclude this. So if we do that, we can see I've got a whole bunch of extra rows. If we consider all the possible future dates, my dates table is pretty large, or it's got a number of future dates. If we do not have this condition here, considering way more dates than we strictly need to. We don't know exactly when it's going to breach, but we know it's definitely not going to be 6 months from now, right? It might be 3 weeks from now, but it's not going to be 6 months from now. So we don't want to even start calculating over those. So we generated our dates. Let's then calculate over those running totals. So we can see we've got our two different sums, getting our running totals, previous and current. And this just generates out all those dates, and we'll get our running totals. And we can see, if we look here, so here's our running totals. How many business hours we use at the end of the day? They're going up roughly by 11 hours, except of course on our Saturday and Sunday, where it doesn't move at all. So that's calculating our non-working hours doesn't increment the counter, our working hours does. So we're getting our moving total. And then our total hours are 44. So we want to find the row where this column here, our SLA hours, falls in between these two columns here. And if we look down, it's this one. So whichever date this is. So we've got 50 hours and 39, which is, that's not as the raise date, we want the breach date. So 14th of April there. And so how do we do that without just looking through the query like this? And we add in some filters to do that. We say fall between those two totals. And I've got all my tickets there. Oh, I thought I had one. Let me just copy these. I thought I got it just for 4,000. So let's put that in there, and we'll see. There's our one row, the date the ticket's going to breach, and falls between the 2 working days, previous and current, and there's our working hours. So we've calculated it for that particular ticket. This is going to breach on, I haven't calculated the breach there. I need to do a little bit more calculation at the end. Add on the number of working hours today. It's a lot of fiddly calculations here. It's always a pain when dealing with dates. There's all sorts of bits and bobs. So there's our 5 tickets. There's our different breach dates. And we can see they're falling various different times. Now, why have we done all this with SQL? Why haven't we written some kind of complex, procedural algorithm to do this? Well, we could, but as I said, what counts as a business date can change, and what counts as working hours can change. So let's imagine we have an early finish on Good Friday. So instead of finishing at 6 p.m., we finish at noon, at 12 p.m. So let's update the working hours for that. We've done that. We'll rerun this query, and we'll see now that the breach dates, or some of the breach dates, have changed. So you can see, in fact, actually, yes, sorry, all the breach dates have changed. These all have been bumped on by various numbers of hours. And returning to the point about if something is due to breach exactly the end of a working day, which day do you consider it to breach on? This ticket, 4,000, raised at noon exactly. When we finished at noon on Good Friday, that means we then used up our hours for that. So the breach here, instead of being on the 14th of April at noon, is the 15th of April at 7 a.m. Is this right? Talk to your business and find out. Find out what they think and mean about that. Will I please maximize the SQL worksheet query? I'm not sure what you're looking for there, Raj. When you say the SQL worksheet query, what exactly is it you want to see? I mean, if you're want to see this, the whole thing doesn't fit on the screen. So this is being recorded. You can see this recording on YouTube later if you want to look through and find the detail. Okay, so we set Good Friday to be an early finish, but of course, actually, at least here in the UK, they are completely not working days at all. So we'll set those to be not a working day and have no start and end date. And again, we'll now find, if we run this query again, so we get that updated. Let's update those 2 rows and run our query again. So again, all the breach dates, or these breach dates, have all moved on again. So we can see everything's now moved on yet another day in terms of when it actually breaches. So this is great now. There's a change in business. We start making Saturday a working day. Well, just have a little app that allows some business user to update the calendar, set it to a working day. Everything just works. You don't need to change any code at all. It all just fits in nicely. So all you need to do, having got this query, most changes we can think of, changing of what is and isn't a public holiday, changing of what the SLA hours, changing of working hours, and so on, all just handles nicely. We don't need to do any more coding changes, making this very self-service, and allowing the business can actually handle this and self-manage itself. Okay, so let me jump back over to the slides. So we've talked about using. Can you post a complete query in a live SQL script? So I'll look at putting the example in live SQL. Well, the complete query is already in the Ask Tom question that was originally the source material for this. So there is a link to this at the end of the session, but I can put it in a live SQL script as well. So Martin, pre-calculating all the dates feels like a relatively expensive query. I'll come back to that point in a minute, Martin, okay? So any other questions, comments before we move on a bit? No? Okay, so this is talking about SLA breach dates, or calculating breach dates for support tickets. And, I'm sure you all work in IT and have either worked on some kind of support desk where you've had to, had pressure to be resolving things within these SLAs, or you've been a customer waiting for people to actually deal with things within the agreed SLAs. So we've all got experience of this as users, or one way or the other, but it's probably not very often you've actually written this type of query. So you think, well, when will I use this kind of thing? When will I do this kind of calculation? And it's true, this is kind of a specific example, but it's actually a fairly common type of problem. And that is calculating when is something going to happen in the future, accounting for non-working days. And here's a few examples I can think of. So delivery dates for goods. A lot of places, the weekend is considered non-working time, and especially Sunday here in the UK. So if something's predicted to be delivered in 3 working days, or done in 3 working days, and you raise it on a Friday, you're not going to get it probably until midweek the following week. Well, that's what the SLA, or the expected delivery date, is. So really common scenario. Another common challenge that we have in IT is estimating, project estimation completion dates. When is a piece of work due to be finished? So again, most places you're not expected to work on the weekends and public holidays and the like. So you need to bump on estimates based on that. Now, to be fair, usually, of course, some project manager will draw some nice Gantt charts and line all these things up to do this, but you might want to have some algorithm to kind of spit this information out. And another thing is calculating payment due date. So again, you've issued an invoice, you said you've got 5 working days to get this paid. You need to make sure you agree what a working day is, and only include those values in your calculation. So these are relatively common scenarios that come up from time to time. So anyone got any other examples where they might have used this, or can think where this would have happened? I'll let you ponder and think about other situations. Okay, so so we've looked at how to do this using SQL, and we have this query to do that. And now, the way a lot of people would approach this is to do something like this. Have some kind of procedural logic to calculate it. So if the priority is, the 24/7, we'll calculate the breach time, just add it on. And if it's not, we'll have this lovely business hours function to actually do that. And in that, well, maybe you'll have some complex formula, or maybe you'll have a for loop. Maybe you've been a bit more smarter, a bit more optimized. You'll come up with some kind of complex algorithm to calculate this. Seems pretty straightforward, right? Well, to start off, it is. But then, as we saw, things like Easter fall on different times of the year. So you need to have an exception in there to handle Easter. What if the date of Easter moves? Yeah, okay, so we need to have our clause for that. Okay, what about Christmas? Christmas Day is always the 25th of December. But the non-working day, or the public holiday, a result of that, has to be a Monday to Friday, at least here in the UK. So we need, if 25th of December is a Saturday or Sunday, we need to bump it on to the following Monday. So we need some extra logic there for Christmas. What about other one-offs? Well, here in the UK, again, the first Monday in May is usually May Day bank holiday, except this year, because it's Victory in Europe, the 75th anniversary of it, celebrations. So we've decided to move that public holiday from Monday to Friday. Okay, so there's all these one-off exceptions as well. Again, well, it was 7-8 years ago now. Some of you may remember a certain royal couple got married here in the UK, and that was declared to be a non-working day for most companies. I think it was the Queen's Diamond Jubilee was also a one-off non-working day. So you can end up with all these exception clauses in here, kind of saying, well, if it's this criterion, if it's that, then we have to do this, and blah, 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 blah. Quickly gets very, very messy to handle all this. Whereas if we've just got it all stored in a table, all we need to do is read those values out. And when those things change, well, the business can go in, use the application, change what a working day is, what is a non-working day. And this is a key difference in philosophy. And there's this quote that I really like. So a code grinder is someone who's going to figure it out, going to do that approach we just kind of discussed, where you've got this procedural, if this, then that, do this, blah, blah, when that happens, so on and so forth. Whereas a database programmer is going to spell it out, have values stored in tables with rows for each individual day or each unit of operation, saying whether or not it's a working day, whether or not it's a non-working day. In general, in case you haven't guessed, I prefer the database programmer approach. It's often a lot easier to debug. Why is this situation happening? Well, we just look in the table, oh, it's got those values, we can modify those and sort it out. It's also much more self-service for the business. As I said, if what counts as a working day changes, or the working hours for a business changes, they just need an app which allows them to change those values. We don't, as programmers, need to do anything. We've done it, it's done. Maybe if there's a big shift in the business, so we need to consider different working hours in different countries, for example, we might need to modify things, but that's a fairly big shift in the business anyway, and a one-off change. These day-to-day changes we don't need to do. So this all sounds great. And coming to your point, Martin, people then look at this data approach and go, but what about performance? Ah! There's like 1 million rows here, the world's going to collapse, right? Well, I don't know, okay? I think it's, getting excessively worried about nothing, to be honest. Let's think about how much data we're storing. Let's imagine you're storing all possible years from the start, all possible days from the start of last century, so 1st of January 1900 to the end of this century, so the end of 2100, 200 rows, or 200 years. That is less than 100,000 rows. In database terms, that is tiny. That is nothing. So, a lot of people kind of get worked up about this being a lot of data, and it just isn't really. I mean, and when it comes to calculating this for an individual ticket, it's pretty fast. We can go back and look at the SQL again in a minute if we've got time or there's no other questions. But I put part of the reason for putting that upper bound for how many dates we consider is to make sure we're not considering the few hundred or thousand rows in the future that we've got for a particular date. We're just saying consider 20 days, 21 days. Is the breach going to possibly happen on that? That is tiny. That's very small. Now, it is worth thinking, okay, what if you want to do a mass calculation of this? What if your business is just large enough that you've got a lot of open support tickets at any one time? You've got, it's a really big company, so you've got thousands of these tickets. Or maybe the support desk are just really bad at closing tickets or issuing updates. So you've got a lot of tickets which are breaching or past their breach date. Now, it is true at this point, they can become slightly slow. So SQL is fast as long as you can identify the rows you want quickly. As long as you can narrow in on a small subset of the data, it doesn't matter how big your tables are. You can have trillion-row tables, but as long as you're getting just 10 of them and you can find them easily with an index, the SQL is still going to be fast. So as long as you can identify them quickly, it's still going to be pretty quick. But calculating breach date for a large number of tickets across the time could get slow. So what about that scenario? Well, we can look at doing that as well. We can just store the breach date. When the ticket is issued, we'll run the SQL to calculate the next breach date and store it in the table. So this is now a column. We can index it. At any given time, there's only, hopefully, or at least hopefully, there's only a relatively small number of tickets which are both active and close to their breach date, going to breach in the next, or past their breach date, or going to breach in the next day. So still, there's going to be relatively few rows we need to find. So if calculating it for everything is going to be relatively slow, we can just store the breach date in the table. Of course, if you do that, you then need to think about what happens when things change. What happens when the SLA hours change? What happens when working hours change? You've got to have, as part of your process to change those, to update all your open support tickets. So another good reason to kind of have APIs or store procedures to manage this. You've got your update to change whether or not a particular date is a working day or the working hours for that date. Then attach into that procedure the process to then update the breach date for all support tickets. So you need to bear in mind that. Worth also mentioning, however, if you are storing this breach date, it can be useful for auditing. So that things have changed. People, whoever owns the working hours app in the business decides to go through and accidentally or whatever updates a whole bunch of days to be working days or vice versa, and suddenly all your breach dates are out. If you've got it stored, you can capture it, audit it, and so on, and see the change of that. So there is a benefit on that side as well. So you can see the change over time of when things were due to breach. Okay, so that's kind of all I had to discuss on this. What other questions or comments do people have before we wrap up and finish? Okay, so comment from Stefan Visser. For those interested in an API for this and building queries around JSON responses, api-workingdays.org. Okay, all right, so thanks. Thanks, Stefan. I'll just say that. Any other questions, comments, things that we want to look into a bit more detail, or we've got maybe 5 minutes if you've got a very quick SQL question that you want to ask. Okay, if you are putting your questions, just point you to a couple of resources. So you're just asking about the SQL for this. A very similar statement, or the same logic you can actually find in this Ask Tom question at the bottom. So that's provided the inspiration for this session. So check that out if you want to see the actual tables and do some testing on some raw data until I've got a live SQL script. Above that, the next working days is a blog post I wrote a while ago, which talks more generally about things like calculating delivery due dates for packages. So we need to skip non-working days. That doesn't account for working hours. It just works at the day level, but similar principles and ideas apply. I also dig more into kind of the performance aspects of that if you want to know more about that there. Okay. Any last questions or comments before we wrap up? Alrighty then. Well, thank you all for joining me. I hope you're all staying safe and healthy and, managing to stay relatively sane in these days where we're all at home all the time. And I hope you've found this useful, and I hope to see you all next time. So thank you, and see you next time.